All right. This is a bit. Oh no. Yeah. Okay. This is a bit of a rough situation. Uh, I guess welcome to class. If you guys can hear me. Yeah, I'm on my phone right now because things are happening. So yeah, guys, welcome. From what I remember, we didn't have class last week, so yeah, I guess we're just gonna pick up from where we left off. Also, can you guys hear me? Type in chat.
Oh, we can hear.
Yeah. All right. Okay. I since I'm on my phone, I don't actually have any class materials with me. So this will be a bit rough.
Do you think we should wait for more people to join?
Yeah, we
We
probably
have
should.
5 people.
Yeah. I guess we'll wait for a couple minutes.
All right, so let's. I guess no one else is going to join. Let's go over the homework. It's homework 5, and it was on tracing code. Let me share my screen. So, wait, just say something. You can see my screen.
Yeah, we can see your screen.
All right. So we went over this last class, but tracing code is a way you can measure, or tracing code is a way you can go through code, and it helps you better understand how the code works and what the code is going to do. So this would be the answer for number 1. You see, so on loop 1, x would be 0. X would be 0 at comment 1, since x initially starts at 0. And after this line of code is executed, x++ adds 1 to x. So x would be 1 after comment 2. Sorry. So yeah, so at comment 2, x would be 1. So what this code basically does is it loops through this 5 times and it adds 5 to 0. So answer would be 5. Is there any questions? All right. So I don't think. Okay. Next page. Tracing loops. So now that you've looked at an example, you can try a problem. All right, let's go through this. So 100 while x is less than 0, x divided by 2. So on loop 1, let's see, comment 1, x is going to start out at 100. So this is going to be 100. After this operation is done, which is, if you look through the slides here, this just divides x by 2. So after this, it's going to be 50. So let's go loop number 2. So we can see here, x is already 50. So our starting value is going to be 50. And 50 divided by 2 is 25. So you can see how this works. It's going to keep doing this all. I'm not going to keep doing it. This is just division. But it's going to keep doing this until x is it's going to do it for a while. So yeah, let's move on. Writing code. I encourage you. Okay, so for this one, we kind of did this in class. Well, we basically did do this in class, but this is the basic template of a chatbot. As you can see, there's like some unfamiliarity to it. Like we haven't talked about classes. We haven't really talked about the driver. So basically what this code does is it lets you write something out, and if it's a certain response like hi, the program will return hello, or if it's bye, it will say goodbye. So this is a pretty simple. I don't know if everyone was here last time for that. I guess not. Okay, so the homework was not that bad. I didn't take a good look at what you guys did really, but it shouldn't be too bad. Does anyone have any questions? No? All right, I'll stop the share for a second. And let me open up IntelliJ. So I'm just going to show off the chatbot. So chatbot's pretty cool. So today I'm planning on just reviewing stuff from 2 weeks ago. Yeah, because we didn't have class last week. So if we just do a bit of review, I think that should be fine. My IntelliJ is not loading. Whatever, I'll just use an online ID. So wait, let me share this real quick. So here's our chatbot. I don't know if Eric's code works. Maybe I have to import. Might be an error. Okay. This is why you probably should use exception and thread main, no such. Okay, this is probably why you should use IntelliJ. Or basically, okay, I can't really show it here, but basically what this code does is the scanner here, scanner class, it allows the user, it allows you to put in information like this, right?
So that black box is the console. And so basically what the scanner does is it just creates an input field where you can type in the console and it'll output a return whatever you put in there in string form in code. So what this does is it allows the user to interact with the code by putting in strings, and it allows you to basically just do different things based on what the user puts in, which is what the chatbot does.
So
Previously with our code, what we did is we used preset variables. Like for example, we just set like different variables to different numbers and added them together. But when you're writing like an actual program, you're not going to have a user go into the code and change around some numbers. If they want to make like a calculator, for example, every time you use the calculator, you'll go into the actual code that it's written to change around the numbers. And so this is a way to get input from the user without having to, knowing how to write code and what to change.
so this is just a very simple example of how this code will work. So you would type something out into the console like hello, and then it goes through this class and it goes through the system, and then after it goes through the system, the data is received by our string of if statements here. So right here, and basically it checks if the message that you sent initially here is the same as whatever it's checking for. And if it is, then it sends a predetermined answer, like how are you or hello. So that's just basically how it works. Don't know why my IntelliJ was not loading. But yeah, so now let's do some review.
All right. So last time we talked about if statements and more complex logic gates. We talked about looping, and we talked about both for loops and while loops. So I'm gonna send a problem in chat. This is typed on mobile, so it might be a bit wrongly formatted, but yeah. So your job is to see what this code signal will output. Either it'll output runs or it'll output nothing. And you guys can just reply in all chat with the answer.
If you guys are having trouble, you can look back on the slides. Slides really do help because I don't really expect you guys to remember this. So I'll share the slides here. I sent the link in chat.
All right, about 3 more minutes for your answers.
Okay, let's go over this. So here's our code. I put in this online ID so it just looks a bit better. Basically, okay, let's look at this. So if you don't remember, a Boolean is a variable that's either true or false. There's no in between. So our first variable is going to be is x, and we're going to set it to true. And our second variable is y, and we're going to set to false. So here we have, this is kind of complicated, but if we can work through it, um, we can break it down and make it simplified. So let's look at each individual parentheses before we look at the entire picture. So in this parentheses, we're gonna say if x and y. So if you don't remember, the and operator is basically saying if both are true, then return true. But if one is false, then return false. So I mean, y is false, so this side is going to return false. So now this false is a part of this huge or statement. So let's look at the other side of the or statement. So this side it says if not x or y. Well, if you remember, maybe you don't remember, but not is the inverse. So x is true here. So not x would make this false. So we have a false on this side. So we look at the other or side. So if this is true, then sorry. If this is true, it would make the entire thing true since it's an or. So you only need one true to make the entire or statement true. So let's look at y. Oh, y is false. So this side is also false. So since this and this are both false, this entire thing is false. So this does not do anything. It doesn't run because, well, okay, technically the correct answer would be that this code does absolutely nothing or doesn't output anything. But yeah, so doesn't print anything. That would be the correct answer. Does anyone have any questions? No questions? All right. Um,
We have another problem in chat now. This is something that we covered 2 weeks ago, which is while loops and for loops can be used in the same applications, but it can also have different results depending on where you place some parts of the code. So do these two things print out the same result? All right, guys, 2 more minutes. All right, so let's go over the answer to the problem. So yeah, the answer is actually these two will not print out the same thing. And that's because if you take a look at the for loop, which I have to. Let's see. All right. Yeah, okay. So our for loop writes for in x equals 0, x is greater than or less than 100, x plus plus, we'll print out x. So there is a order that we are running these in. There's a specific order. So inside the parentheses, we see that we have int x equals 0, x is less than 100, and then x plus plus. So we'll actually run int x equals 0 first to initialize the variable. And we run this only once. And then we have the conditional x is less than 100. And we'll check this at the beginning of every for loop. Hold up. So yeah, this runs at the beginning of every loop to check if the variable is less than 100. And if it is, then it'll run. And if it isn't, then it'll stop. And then we actually run system.out.println x. So we run the what's inside of the curly brackets, the curly braces. And then after that, we add 1 to x. So if we do the code tracing, which I can't exactly screen share it because I'm on a phone. But yeah, if we trace the code, we'll see that on the first run, on the first pass through, x is equal to 0 when we print it out. But on the second pass through, we'll see that x is equal to 1 since we added 1 to the last, at the end of the last loop. And we keep doing that. So it'll count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 99, and it'll stop there. Because after on loop number 99, it'll print it out, it'll add 1 to x, and then it'll be 100. And at the start of the next loop, it'll see that 100 is not actually less than 100, so it won't run. So it'll print out all the numbers from 0 to 99. But if we take a look at the while loop, we see that we have basically the same structure. So there's a few key differences. We start off with the int x equals 0 outside the parentheses for the while loop. And then we have the conditional in the parentheses, we have the increment, and then we have the print. And that's why these two are different, actually. It's because the increment comes before the printing. So if we run through the code, we see we initialize int x equals 0, and then we check x is indeed less, or 0 is indeed less than 100. And then we add 1 to x, and then we print it out. So by the time we get to the print statement on the first loop, x, the one that we print out, is actually 1. It's not 0. So we end up printing out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up. And we end on the last one. We see that on the 99th loop, hold up. All right. So yeah, on the 99th loop, we see that x bnx is 99, and we go through the loop. We add 1, it turns into 100, and then we print it out. So at the end, the last number that we print out for the while loop will be 100, whereas with the for loop it'll be 99. Do you know how we can modify the code? Or I guess here's the next question: how can we modify the code in order to make these two print out the same values? And I'll give you guys a couple minutes to solve this one. So how can we modify the while loop so that it prints out the same value as the for loop?
What are we doing right now?
So, oh, you just joined. So there are two code segments.
As the for loop.
Basically, they print different things, but how do we make the while loop print the same thing as the for loop here?
Yeah. So the for loop prints out all the numbers from 0 to 99, but the while loop prints out all the numbers from 1 to 100, inclusive for both of them. So how do we make so these two have the same output? Or makes it so the while loop has the same output as the for loop.
All right, we'll give you guys like 7 more minutes.
All right. So the correct answer for the question was to swap the position of the plus plus and the print line in the while loop so that your code would look something like while oops, that was not what I meant to do. Well, x is less than 100. And like this. And that would make it so that the output of your code has the same as the output for the while. Sorry, before. All right. It's 3:50. Let's take a break right here, and then once we get back, we'll get into some new content. 10-minute break, by the way. All right. Yeah. I guess 10-minute break is technically over, but I'm still getting my screen sharing account set up. So yeah. I guess you guys have a few extra minutes on your hands.
All right, our break is over. So yeah, I think we should just do a bit of review first. So give me a second. Okay, let's review loops. Okay. Okay, here is, yeah, so loops, we did this, I think 2 classes ago, or no, 1 class. So, so before we even went over loops, we went over operations, and I think most of you guys should have this down. It's like the basic adding, like this would add 1, this would also add 1, same with this, and this would subtract. So yeah, pretty basic. Else if it's an add-on to the if statement. Basically, it's just another compounded if statement. But notice the difference. Wait, can I exit this? This portion of code is not the same as this. Notice. Big difference here. Let me make this, sorry about that. Make this a bit smaller. Okay. So these things are not the same thing. Notice we have the else if here, and this is a completely different statement. So what are the differences? Well, in the case of 2 if statements on top of each other, they almost act as separate entities. So this first thing is going to run This first thing is going to run by itself and it's going to be secluded. So it's going to check if x is equal to 4 and well, x is not 4, so this isn't going to do anything. And this code is going to check if y is not equal to 4. And since y isn't equal to 4, it's going to print. So the main difference, okay, let's hypothetically let me remove these. Wait, clear. Let's say x was equal to 4 in both cases. Well, the output would be completely different. Okay, to put it simply, the else if only activates, the program only checks if this first part isn't true. So in this case, okay, x is equal to 4, y is equal to 5. The program is going to come down here. It's going to see, oh, x is equal to 4. So we're going to print this. And what it's going to do, this is something very important, is that it's going to completely disregard this bottom side. Since we already have this as completed, so we don't need to check additional things. It's like, imagine if this was an else. Like if you made an else statement, imagine if this was an else statement. It would not check it. It only checks the first part. And that's a topic that's a recurring topic that can be applied to other parts of Java. Like for instance, an or statement where you have something like this. This is what we call short circuiting, kind of, where it looks at the first value, and if the first value is enough to satisfy the answer, you're not even going to look at the second value. So in the example of an or statement, what an or statement checks is if one of these is true. So Java is going to come along, it's going to look, oh, this is true. So we don't even have to check the next one because we already know the first one is true. So we disregard this. So the same goes for an if else statement or an if else if statement. So basically this is going to come along. Since this is true, we don't need to look at this since the program's just going to skip it. But if you did want the program to check this as well, you would just split the if statements into two separate parts. So in this example, the first program would print x is 4, and the second program would print x is 4, and then it's going to print y isn't 4. Do you get how that works? Since this part is a part, this is one thing, and these are two things. So they're separate. All right, let's move on. So we just went over logic here. So logic gates, they allow us to do comparisons between Booleans. So Booleans are also kind of important, but basically what I want you guys to think when you hear Boolean is true, false. That's what I want you guys to think. If something is true or something is false. That's that's basically what a Boolean is. It's like you know how an int is a number without a decimal. So like 1, 2, 3, whatever, 200. A Boolean is just a value that is true or false. So when you hear Boolean, think true or false. So let's continue. Logic gates are the smallest computational unit of your computer and process binary into useful information to the user. So the reason why Booleans are important is because unlike humans, computers can read zeros and ones. So when you write your code, it's going to go into the, so here's your code, right? And we have this thing called the compiler. Compiler that processes the code. So we have our code, which is something that we can understand as human beings. It's a form of language. So the question is, how do we make it understandable to the computer? Well, one way we would do that is with the compiler, which basically turns it into a binary, which is, if you don't know what binary is, it's just ones and zeros. This could be understood by the computer, and then the computer can do what you want it to do. So basically, think of this as like a translator. So we translate our code from something. So if you want to translate something in Spanish, you want to talk to like some Spanish person, and you want them to, like, say you're at a restaurant and you want to order something. Well, you would have to say something in English to like a translator, and then the translator would have to say something in Spanish. So just think of that as like this is as a translator. It translates into language that the computer can understand. So yeah, so this is binary into useful information to the user. So the computer does what you want it to do. So your computer is made of trillions of logic gates, each doing thousands of computations per second. 1,000 of these logic gates in a line could fit along the diameter of a human hair. So basically, these logic gates, it's like a way. It's kind of like a brain. So we pretty much made like a machine brain, but like a very simplified version of it. So define what logic gates do. Look up the truth tables. Okay, so Boolean algebra. That's cool. Let's move on. So yes, it just returns true if input is true and false if the input is false. You don't really need to know this. Not gate reverses the input. So true turns into false and false turns into true. So if something is not true, it'd be false. If something is not false, it'd be true. If something is not, okay, let's just move on. I will give you an example and ask you what you guys think. So the AND gate sees if both input X and input Y are true. If they are, then it returns true. So basically, if you say, so in this example, 0 is classified as false and 1 is classified as true. So if this is true and true, then the output would be true, true and false, output would be false, false and true, output false, false and false, output false. So let's have an example. So one interesting thing you can do with logic gates is that you can use them similarly to mathematical expressions, Boolean algebra, as you remember from the previous slide. So you can do something like this. So what do you guys think this would do? I don't know if you got to this part of math with distribution. What do you think this would do? So we have not, and then in parentheses, true and false. So remember, this one is true, 2 is false. Anyone? Someone type it out in chat. If no one types it out, I'll call on someone. Don't worry, this is it takes some time to understand, but once you understand it, it's as easy as addition and subtraction. Just think about it. Okay, I'll ask someone. How about Zoe? What do you think this will output? Or what do you think this entire value will be? It's okay to be wrong. So that's what we're here for.
2.
2? Okay, so you're basically saying this is going to be false. All right, let's look at this. Let's just look at this first. So when we approach a problem, when we approach any problem that we might not know the answer to, our first step should always be to break down the problem and simplify it. So before we even look at this starting part, let's look at the inside here. So if something is true and false, this should not be 2, my bad. This is a 0. Sorry about that. It should be 0. So if something is true and false, what would it be? To make it even simpler, since true is 1, and false is 0, 0. So if we have 1, 0, what would it be?
0.
Yeah. So we have 1, 0 here, and 0 is going to be our answer. So we have 0 for this part. So this whole thing is going to be equal to 0 or false. So now instead of this, we can turn this entire expression. Let me erase this first. We can turn this entire expression into this. Not false or not 0. So what we learned from the last couple of slides, the NOT gate reverses the input. So it turns true into false and false into true. So since it reverses the input, it's going to reverse false. So the inverse of false is going to be true. So we can take this and we can find our final answer to be true. Do you understand? So just by simplifying the problem, not looking outside the parentheses, we can make this, we can easily solve the question. So let's move on. So now we're on a separate logic gate, which is kind of like the inverse of AND. So the OR gate sees if input X or input Y is true. If so, it returns true. So basically, this is just saying if X or Y is equal to 1, then return 1. Just think of it as like X plus Y. So if it's 0, if it's false or false, it would be like 0 plus 0. What's going to be 0? If it's 1 or 1, it would be 1. Or it would be positive, which would make it 1. Or if it's 1 and 0, it would be 1. So let's do another example. I'm going to give a tougher one. 0 and 0, 1 and 1. So here we have an even bigger expression. So we're taking the OR of this expression. We're comparing these two expressions, this and this. And then this is the thing in whole. So let's break down this question. So 0, okay, let's just define 0 as false and 1 as true. Or if I can make this text bigger. Oh, whatever. 0 is false and 1 is true. So I will call on someone. I would like someone to tell me what is the value of this? 0 and 0. If something is both false, if they're both false, what is, we just want to, this is the
0.
and. Yes. 0 and 0 is going to be 0 because neither of them are true. So we can break this down. This expression can turn into a 0. And now let's look at the other side of the OR expression. If it's 1 and 1, what is this expression going to be?
1.
Yeah. So since both are true, it's going to be 1. What if it was 1 and 0? If this was 1 and 0, what would it be?
1.
No. Don't let this fool you. This is and. If we look back at here, the AND gate sees if both input X and input Y are true. So if they're both 1, it's going to be true. But if it's not both 1, then it's going to be false. So if it's 1 and 0, it's going to be 0. So, yeah, that was kind of a trick question. So let's pretend this is 1. So since this is 1 and 1, it's going to be 1. And now we have this expression, 0 and 1. Now, you can obviously look at this and you can see, but if you understand the concept, like there's a 1 here already, and we know that since there's only 1, it's going to be 1. That's our final answer. So, yeah. That's the OR operator. Let's move on. So now we have more logic gates. I don't really need to know these. They're cool to know, but we can just move on. So loops. So loops will be useful when we need to do something multiple times. We've already showed you guys, exposed you guys to loops, and I don't know, sometimes they can have really weird properties, but more you experience them, more you'll understand. That makes sense. So this is a while loop. Basically it depends on these 3 things. It depends on this first initial variable. It also depends on this part, the actual while loop. and it depends on the increment. So without these three things, the while loop would not exist. Let's take a look at the cases in which in why we need these things. So let's start off. So imagine just imagine we don't have this first variable. Well, the while loop is not going to be able to run because it doesn't have any benchmark to run it between. There's nothing for it to use as a base. So what I mean by that is that when it runs, it won't be able to compare itself with the outside code. And it's either going to run forever or it's not going to run at all. So, for example, when you ask the expression while something is true, if you don't know what that something is, like say while my dad has black hair, I'm going to get my hair cut. If you don't know what if you don't know what your condition is, you'll never be able to run it. So that's the reason why we could not delete the variable. The reason why we could not delete the increment, well, okay, sometimes we can. This is an exception. Sometimes we can delete this part, but only if this part is something different. Like, for example, int I'll just for example, we can use the Boolean in this example as the Boolean variable. So we have something like this, and we can have this. Something like this, or we could have something like this, or you could just do while true. But this would make an infinite loop. You don't want to really do this that much. Actually, you don't want to do this at all. So in this example, just say while this is true. Well, true is always going to be true, so this is just going to run forever. If you look at this example, it's similar, but a reason why we could use this is because if we want to like put in another portion of our code, Boolean, for example, like I don't know, there's not, you can't really use this example, but we could say like high equals false, and then this would stop running. So that's just like the one exception. But when you have an int variable as a counter, you always need this increment. It's very important. So yeah, those are the parts of the while loop that you actually do need. Now a for loop, or well, we just went over this. Okay, I'm going to skip over that. So a for loop is kind of, think of a for loop as like kind of like a condensed while loop. So we take all the portions of the while loop and we put it in the for loop. So this would be our variable. This would be our like method of, this would be our condition. That's right. Condition. And this would be our increment. So these three things are very important to the while loop and the for loop. And as we can see the same things here. So here's our variable. Here's our condition. And here's our increment right here. Should probably use different colors. But you can see the gist. these three things are all pretty similar. So yeah, those are for loops. A lot more compact and probably better to use. But it depends on what you would use it for. So I think that's the end of the slides. Does anyone have any questions? And wait, how about we practice this before we end the review? So take a good look at this code. I'll resend the link. I sent this earlier, but this is the link. This is the link to the loops. I suggest you look through it. If you're having difficulty solving this problem, just send your answers in chat when you are done. I'll give you guys 5 minutes. I think that's well enough, over enough time. So I want you guys to send me in chat what this code does. Okay. So I guess time is up. Um s- kind of hard question. It mixed while loops with if statements. Um let's take a look. So okay, so this is our starting variable. As you remember, variable. This is our condition, and this is our increment. So before even looking at this code, I can already tell that this code is going to run 100 times. Just with these three things, because I know that it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 99. So we can already know that this is going to run 100 times before I even do anything. So I know it's going to print probably, or it's going to run this whatever's in here 100 times. So let's use what we learned 2 weeks ago, or a week ago. 2 weeks ago. So we went over tracing code, and this would be a perfect time to do it. So our first loop, so we're going to write down loop x value, and this x value is going to be here, comment. So okay, so let's see. So on loop 1, we're going to have, let's just call this point B, and then we have point A. So x at A and x at B. Very simple. So, okay, first loop, x at point A, well, it's going to start at 0, so this is going to be 0. This does nothing to x. So we just know, we know that x is going to keep incrementing like this. So very early on, since this is just an if statement, it does nothing to x, we can determine that x is just going to go up, increasing. Wait, this is wrong. So now that we know that x is just going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 99, we don't need to count x anymore, and we could just look at what's going to happen. So since we know that this is going to exist, since we know it's already going to exist, x is going to be through every value, we can look here. So x is greater, so for every value of x greater than 50, we want to print x. So if 99 is greater than 50, we're going to print x, which x is going to be 99 in that case. So we can just look through these. So 0, well, 0 is not greater than 50, so it's going to print less than. Same goes for 1. Same goes for 2. Well, let's say what happens at 50? Well, 50 is not greater than 50. 50 is 50. So this isn't going to work. And instead, we're going to look at the second part. Well, the second part says print less than. So we're going to print less than at 50. And you can, or not, okay, yeah, we're going to print less than at 50. And what if it was, oh, What if it was greater than 50? Right? What if it was greater than 50? Well, we look at the code 51 after 50. So since 51 is greater than 50, we're going to go to this part. This line is going to be executed. We don't care about this part. We don't care about this part. We only look at this. And since instead of X, we're going to have 51 here, we're going to print 51. So on 51, it's going to start printing 51. And we can just replace this with 52. So on 52, it's going to start printing 52. And you don't even, at this point, you don't even need to look through each individual case. You can just estimate, you don't have, not even estimate. You could just notice a pattern that for every value 50 or below, the program will print less than. And for every value greater than equal to 51 or greater than 50. My bad. We're going to print that value. Print value. So that is the answer. Yeah. This format's a bit confusing since it goes from largest value on this side, and this is the smallest value or smaller values. So that's a bit confusing. Okay, we don't have many people today, so I kind of don't want to go over new content, but you guys could also be ahead if you want to. And okay, I'll let you guys decide. Would you guys prefer to go over new stuff today or just like do some more practice? Okay. Okay, so there's other okay. So I think the general consensus is practice. So
I mean, we can go over new stuff today. I'll just make a video for the people that weren't here.
oh, I don't think that's smart. I think it's better to like do a, like get the base down
Yeah,
before
alright.
we go over new things.
All right, let me pull up IntelliJ then.
Okay, I have this code. I'll share it. And send your answers in the chat when you're done. Then don't worry about being wrong. It's actually better to be wrong because then you know what you have to work on. Well, okay, technically it's not better to be wrong, but it's good to be wrong. It's not bad to be wrong. I'll just say that. Okay, let's go over this. So, I mean, Danny was technically correct, but that wasn't really the answer I was looking for. Um, so let's take a look at this. So we can track our code here. So we trace our code. My bad. So we have loop, and then we have test. So we're going to see the value of test at the end of each loop. So that would be like here. So okay, loop 1, we're going to go into this. So test is 100. So while 100 is less, 100 is greater than 0. We're gonna take 100 and we're going to subtract 1 from it. 100 minus 1. That's going to be 99. And then we're going to print out 100, or not 100. We're going to print out test. So here we set test to 99. And here we're going to print out whatever test is. So since test was 99, we're going to print out test. So test is going to be 99. Let me first print it out. So now let's go to loop 2. Loop 2, okay, we don't have to look at this part since we're already in this section. So 99 is greater than 0. So 99, let's look at this. So test the variable is equal to 99 minus 1. Okay, 98. So 99 minus 1 is 98. So 98. Okay, so we can obviously see a pattern here. It's going to be 97. Now that we know the pattern, we got to see what happens at the bottom. So let's go to the bottom. So whatever loop this is, I don't know. It's probably like, let's see. Okay, let's just go to like loop 99 or loop 98. So on loop 98, we're going to have this 98 times. So test is going to be equal to 2, right? Or am I wrong? Yeah, I think it's right. I might be off by 1, but it shouldn't really matter. We all we're doing is seeing. Okay, let's just say test is equal to 2. So on the next iteration, let's just cross this out. On the next iteration, so 2 is greater than 0. 2 equals, or test equals 2 minus 1. Okay, we're gonna print out 1, and now that's 0. Well, 0 greater than 0 is not true. This is not right. This is not true. So this is going to be false. And since our condition is false, our while loop stops. So this thing stops, which we want it to. We never want a loop to go on forever. So our loop is going to stop when test is equal to 0. You got that? So what our code in reality does, now that we can look at our tracing, is that our code prints all the values from 99 to 0 inclusive. Well, what that means is it prints 99, 98, 97, 3, 2, 1, 0. So that is our final answer. Does anyone have any questions? So yeah, so Danny, you got the idea of how, like, this will not run if test is 0, or if test is less than 0. This will not run, but you have to go a bit more in depth. So yeah. think we'll have homework 6 up soon. It'll probably be up by Monday at the very latest, but expect it to go up on Sunday. So I don't really have anything else to say. There's homework, or there will be homework. Just check, and don't be afraid to ask questions or like search something up, because internet is probably your best resource. So yeah, we're pretty much done. So you guys can leave. Class is dismissed.